Okay, I'm going to be working on section 6.6, which is improper integrals, and I'm going to be working through the odd problems, starting with number 5, and then I'll work through probably through 31. Uh-oh. Okay. Get a little bit of water in here. All right, so the first problem that we'll do, number 5, is integral from 3 to infinity of 1 over x minus 2 raised to the 3/2 dx. All right, so what we have here, remember there's two types of improper integrals that we're looking at. Type 1 were called infinite intervals, and that would be where our interval is actually infinite. And then the other type that we have in this section, the type 2, is a discontinuous integrand, which would mean that we have some discontinuity inside the integrand here, somewhere where maybe the denominator goes to 0 when the numerator goes to a fixed number. So with those two types of integrals in mind, let me first just take a look at the number line and realize I'm integrating from 3 to infinity. So if here's 0, here's 3. I'm looking out this direction forever, and I'm trying to find kind of like the area underneath this curve. Now, I don't really know what the curve does. Let's see, at 3, if I plug 3 in here, I get 3 minus 2 is 1. 1 to any power is 1. 1 over 1 is still 1. So I know I'm up here. And then as x gets bigger, as this gets larger, this ratio gets smaller. So I know that this does drop down like this. And I'm trying to find the area underneath here forever, to the right. Now, what I also need to consider here is whether or not my discontinuity is in my interval. So we can see that if we let x be 2, we get 0 here, and we're going to have a discontinuity. But 2 is not in my interval. 2 is here, so I'm not even going to consider that. So the approach here now, that I have an idea of what it looks like, is to rewrite this using the definition. This is going to be equal to the limit as t goes to infinity of the integral from 3 to t, and then the integrand, 1 over x minus 2 to the 3/2 dx. So all we do with these type 1 integrals is replace the infinity symbol with t, and then we do a limit. So we work this out as if t is a fixed number, and then at the end of the problem, we'll let t go to infinity. So this antiderivative here, we need to determine, and that can be done with a simple basic substitution. So I'll show a substitution on this problem in the future. I may not do this. We'll just see how things go here. If I take this integral, and let's turn it into an indefinite integral. This is what we spent a couple of weeks on. If we're trying to find the antiderivative here, we can just let u be equal to x minus 2. Du can be just dx. And then I can rewrite the integral as 1 over u to the 3/2 du. And that's just the same as integral u to the negative 3/2 du. Let me shut this door real quick. All right, now we're going to actually just use the power rule. So I'm going to add 1 to this. If you add 1 to that, you get negative 1/2. So this will be equal to 1 over negative 1/2 u to the negative 1/2 plus a constant. But whenever we're doing definite integrals, we don't need to consider the constant of integration because it's always going to cancel out. I'll probably show you that in class. So this is going to be equal to, well, we flip and reciprocate there. So it's negative 2 u to negative 1/2. And then u was x minus 2. So negative 2 x minus 2 to the negative 1/2. All right, that's my antiderivative. So I'm going to come back over here now, and I'm going to write limit t goes to infinity. And then I have, let me put in parentheses here, negative 2 times x minus 2 to the negative 1/2. And then I'm going to evaluate that, because I've actually taken the antiderivative, I'm going to evaluate that at 3 in t. All right, so this is what we talked about in class. This is the fundamental theorem of calculus. You find the antiderivative, then you evaluate at the two endpoints. You subtract. So now I have, I'm going to keep my limit, keep writing my limit as I go here until I actually take the limit. I have limit t goes to infinity of, all right, in here we're going to have two things. All right, we're going to have what we get when we plug t in, then we're going to have what we get when we plug 3 in. So since I'm always going to have that format, I'm going to do 2 sets of parentheses, and then I'll close off the parentheses for the limit. So I'm going to plug t into here. If I do replace the x with t, it's just going to be t. Also, while I'm doing this, I'm going to rewrite this. This is going to be -2 over x minus 2 to the positive 1/2, because I'm dropping it down, but positive 1/2 means square root. Oh, forgot to replace the x with t. And then I'm going to do the same thing, -2 over the square root of, now I plug 3 in here, 3 minus 2. All right, so now I just need to figure out what this is. So if I let t go to infinity, if t goes to infinity, I know that this becomes infinite. Square root of infinity is still infinity, and then I have a fixed number over infinity, which is going to go to 0. So we have, on top it's -2, the bottom is headed towards infinity. That ratio will get smaller and smaller, which means that this one will go to 0. Minus, now over here, 3 minus 2 is 1, square root of 1 is 1, -2 over 1 is -2, so I'm going to subtract -2, and so the result is positive 2. So the area underneath that curve from 3 over to infinity forever, that area is converging to 2. And that's it for that one. So now let's take a look at number 7. Integral -infinity to 0 of 1 over 3 minus 4x dx. All right, so again, I'm going to take a look at the interval here. Here's 0. We're going out this direction to infinity, and whatever the function's doing, I'm trying to find the area underneath that curve to the left of 0. So what I also need to figure out is, do I have a discontinuity in this interval? So I take a look at the denominator and I ask myself, when is that 0? Make sure it's not in this interval. So if I take this and I solve this for x, I get 3/4, positive 3/4, which is over here. So my discontinuity is not in my interval, so I don't need to consider it at all. All right, so next thing to do would be to actually determine the antiderivative of this. I'm not going to go through the work, but if you made a substitution, u is equal to 3 minus 4x, du would be -4 dx, and then you could scale, -1/4 du is dx, and then you go through and you rewrite this, and what you would get is this. So I'm going to actually write this down, rewrite this as limit as t goes to -infinity of integral t to 0 of 1 over 3 minus 4x dx. And then using that substitution, I find the antiderivative of this. So again, I'm not going to show that. But this will be equal to the limit as t goes to -infinity of, now, here's my antiderivative. It's -1/4 natural log of 3 minus 4x. And then evaluated t to 0 like that. Then I know that to evaluate this, I need to split this up into two pieces, plug in 0, plug in t. So I'll do that up here. So this will be equal to limit t goes to negative infinity of, let's see, two things here. So first we plug 0 in. So 4 times 0 is 0. 3 minus 0 is 3. So I just get negative 1/4 natural log of 3. Then I plug in t. So t goes in here. I just rewrite the whole thing. Negative 1/4 natural log of 3 minus 4t. All right, that's this t in here. And then at the end, I let t go to infinity, or negative infinity. So we have to pay attention to the signs here, make sure all this works out. So nothing happens here. So I have negative 1/4 natural log 3. And then here, if I let t go to negative infinity, I have a negative 4 times negative infinity. Really, you can't really do that, but a negative times a negative is positive. So I get 3 plus a number, and that number is becoming infinite. So really I'm saying what's natural log of an infinitely large number? We take a look at the natural log function, which looks like this, and we ask ourselves what happens as we go to infinity. So as we go out here, the function actually continues to rise slowly, but it does go to infinity. So I know that this entire thing goes to infinity, and it doesn't matter, I'm multiplying it by negative 1/4 and then subtracting it. The idea is that this whole thing becomes infinite. So I've got something like this, an infinite number. So the area under the curve is this constant plus an infinitely large number, which means that it doesn't go to a specific number. So we say that this diverges. And we're done. Hey, what's up? Good. They're using that other conference room for something else. What are you working on? Okay. Yeah? Yeah.
And it's the algebra that's screwing me up. It's mainly the system of equations.
Okay. Are you working on the homework problem for the online class or the?
Well, I was stuck on one of them, but
Okay.
I'm doing both.
Okay. Well, do you have a question? Because we can go over something.
Yeah.
Okay. Forgot your book?
No, I don't have mine on the laptop. I think I can look it up on my phone.
Yeah. All right, you look it up. I'm going to work through this one real quick.
Okay.
Okay, so in this one we're integrating from 2 to infinity, so this way. And then e to the negative 5p, that doesn't ever have a discontinuity, so I don't need to worry about it. So I just need to find the antiderivative here. So let me first change this over. Limit t goes to infinity of the integral 2 to t. And then now e to the negative 5p dp, which equals the limit as t goes to infinity. And now let's get my antiderivative. So the antiderivative of e to the negative 5p is negative 1/5 e to the negative 5p. I'm evaluating that from 2 to t. Now, to do this integration from here to here, I actually looked at this and did a basic substitution. U is equal to negative 5p, and then du is negative 5 dp, and then I scale negative 1/5 du is dp, and then I rewrote the integral, and then it got me this. So I'm not showing that. And now all I have to do is plug in the two ends or two endpoints of the interval, which are t and 2, and subtract those two. So I'll do that up here, remembering that I have a limit sitting out in front of everything. Limit t goes to infinity of, I'm going to have two things being subtracted. So first I plug t in for p, so I get negative 1/5 e to the negative 5t, and then I plug in 2, I get negative 1/5, e to the negative, let's see, 2 times 5, so negative 10. All right, now this is a little bit tricky, so you got to be a little careful with this. You need to figure out what happens when t goes to positive infinity right here. So if I take a positive number and multiply it times negative 5, this is a negative number. So we're really asking ourselves, what happens if you take e and raise it to a number that's really, really big but negative? And there's two ways to look at this. One way would be you look at the e function, the exponential function, looks like this. And when you say take e and raise it to a very, very large negative number, that means you go out here, way out here on the x-axis and pick a very, very large negative number and then do e of that, and it's going to be a very, very small positive number because this is approaching 0. So we can say that this heads to 0. That's one approach. The other approach is to rewrite this right here as 1 over e to the positive 5t, so negative exponents drop down. And then when you let t go to infinity, this really turns into 1 over e to the positive infinity. And now you're looking, what does e do if you go out to positive infinity? So if you go this way, e gets very large, and so you have 1 divided by a really, really big number. That ratio gets smaller, so you get 0 here. So either way you do it, you're going to get 0. So this right here, when you take the limit, it goes to 0. And then this over here, nothing happens to it when t goes to infinity. So what you're left with is just this piece. So the negative and or minus the negative becomes plus, so you get 1/5 e to the negative 10. You could leave it like that, or you could put 1 over 5e to the positive 10. And e to the 10th power is some number, and then times 5, and then divide that into 1, and that's a number. So this interval converges to that value. Did you find it? Okay. All right, integral. It's number 9. 0 to infinity. Just let me know when you get it, okay? All right, on this interval, or this integral, we're looking from 0 to positive infinity, so we're looking that way. The only place we have a discontinuity is when this is 0, and that's going to happen if x is negative 1. If x is negative 1, that becomes 0. But negative 1 is over here, so I don't need to consider that. All right, so before I begin this, I'm actually going to take a look at this integrand. Make sure I can integrate this before I proceed. So I'm going to set up an indefinite integral real quick and try and figure out how to integrate this. And after looking at it for a few seconds, minutes, hours, I don't know, it'll depend on you, you'll realize it's just a basic substitution. And we have the derivative x squared dx. We've got the derivative of this up on top, so we can rewrite this integral as integral, let's see, this part right here is going to be part of our du, and it's 1 over the square root of u, so 1 over root u. And then this x squared dx becomes the 1/3 du, so 1/3 comes out du. And this is really just 1/3 integral u to the negative 1/2 du. And then we integrate 1/3 times, we add 1 to this, we get 1/2. 1 over 1/2 is 2. U to the positive 1/2 plus a constant. And that's just 2/3 u, but u was 1 plus x cubed to the 1/2, which is the same as the square root. So I'm going to come back over here. I'm going to rewrite this as limit t goes to infinity of the integral from 0 to t of x squared over square root 1 plus x cubed dx. Now find the antiderivative, which we did already. So limit t goes to infinity of this antiderivative, which is this, 2/3 square root 1 plus x cubed, and we're evaluating 0 to infinity. And you can see what's going to happen here. Limit t goes to infinity, or sorry, yeah, infinity of, we have two things being subtracted here. So if I go to infinity here, this becomes infinite. Square root of infinity is still infinity times 2/3. So this is becoming infinite. And then over here, if we plug in 0, we just get what, like a 1 in here, and then we get 2/3. So this is becoming infinite, and that's just going to the number 2/3. So this whole thing blows up, becomes infinite, which means that this integral diverges.
I got
You
it.
got it. You want to work through the whole thing, or you have a specific question, like at a certain point? What do you prefer?
This one, I get stuck.
You get that email about the bonus?
Yeah.
Okay.
But I think it's already over.
It's what?